Hi everyone, welcome to KMLS Chemistry channel. In this video, I will be presenting the first part of Introduction to Organic Chemistry. In this slide, I will demonstrate on how to convert condensed structure into skeletal structure. The first compound. Begin by numbering the carbon atoms. There are 4 carbon atoms. Now place your pen on paper and start writing a stroke. Can be an upward or a downward stroke. So this is carbon 1 bonded to carbon 2. And just move on to the third carbon. Next, the 4th carbon. So this is the skeletal structure for the first compound, butane. The second compound, begin by numbering the carbon atoms. There are 3 carbon atoms in the parent chain. Place your pen on paper and start writing a stroke. Carbon 1 bonded to carbon 2 and just move on to the third carbon. So this is the parent skeletal containing 3 carbon. Moving back to the condensed structure, the third carbon is triply bonded to a nitrogen atom. This is the third carbon. Write 3 lines and attach the nitrogen atom. So we are now done with the skeletal structure for the second compound. The third compound. This is a cyclic compound. It has a carbon ring. Begin by giving numbers to the carbon atoms. You may start numbering from any carbon atom because the numbers are just to be used as guide to sketch the skeletal structure. So there are 5 carbon in a ring. What you need to do now is to draw a pentagon. A pentagon has 5 corners. On every corner there is a carbon atom. Carbon 1, 2, 3, 4 and 5. Getting back to the condensed structure, the second carbon atom attach a chlorine atom. So this is the second carbon atom. Draw a line and attach the chlorine atom. We are now done with the skeletal structure for the third compound. This is the 4th compound, butanol. Start off by numbering the carbon atoms. There are 4 carbon atoms in the parent chain. Place your pen on paper and start writing a stroke. So this is carbon 1 bonded to carbon 2 and continue to the third carbon followed by the 4th carbon. This is the parent skeletal. Getting back to the condensed structure, the third carbon is doubly bonded to an oxygen atom. So this is the third carbon, write a double bond and attach the oxygen atom. This is the skeletal structure for this compound, butanol. Now let's move on to the next compound. Begin by numbering the carbon atoms. There are 3 carbon atoms. Place your pen on paper and start writing a stroke. This is the first carbon bonded to the second carbon and just continue to the third carbon. This is the parent skeletal. The third carbon is attached to an OH group. So this is the third carbon. We have to write a line and bond the OH group. The first and second carbon are doubly bonded. So we have to add another stroke between the first and second carbon, forming a double bond. We are now done with the skeletal structure for this compound. Now move on to the next compound. This compound has 2 continuous carbon chain. The straight chain carbon and another bend chain. The straight chain carbon has 1, 2, 3, 4, 5 carbon. And the band chain has 1, 2, 3, 4 carbon. Which means that the straight chain carbon is the parent chain. So now we will give number to each and every carbon in the parent chain. There are 5 carbon atoms in the parent. Start writing a stroke. So now I'm showing a downward stroke. First carbon to the second, to the third, fourth, and the fifth carbon. So this is the parent skeletal. The third carbon has a carbon branch. So this is the third carbon. We're going to write a line. And at the end of the line, there is a carbon. But we don't need to label the carbon. In skeletal structure, we don't need to write or label the carbon and hydrogen atoms in the parent chain as well as the carbon branch. So we are now done with the skeletal structure of the last compound here. In this slide, I'll be doing the opposite, that is converting skeletal structure to condensed structure. The first compound. Number the carbon atoms. There are 7 carbon atoms. What I'm going to write now is 7 carbon atoms in a row. Getting back to this structure, the fourth carbon has a carbon branch. So this is the fourth carbon, write a line and attach a carbon atom. The fifth carbon attach a hydroxyl group or OH group. So this is the fifth carbon, write a line and bond the OH group. Carbon number 6 also has a carbon branch. So this is carbon number 6, write a line and attach the carbon branch. So we are now done with the parent skeletal as well as the branches. The last process is to fill in the hydrogen atoms appropriately. So to count the appropriate number of hydrogen atoms on each carbon, we get back to the skeletal structure. Carbon number 1 has 1 bond right now to carbon number 2. Each carbon atom can have a maximum of 4 bonds. Since carbon number 1 already has 1 bond, the remaining 3 bonds are actually attaching 3 hydrogen atoms. Carbon number 2 has 2 bonds, one to carbon 1 and the other to carbon 3. The remaining 2 bonds are attaching 2 hydrogen atoms. The third carbon also has 2 bonds right now. The other two bonds will be attaching 2 hydrogen atoms. Carbon number 4 has 3 bonds, 1, 2, 3. So the last bond, the fourth bond, will attach a hydrogen atom. Carbon number 5 also has 3 bonds right now, 1, 2, 3. So the last bond is attached to a hydrogen atom. Carbon number 6 also has 3 bonds, 1, 2, 3. So the fourth bond is attaching a hydrogen atom. And the last carbon, number 7, terminal carbon, it has only 1 bond right now to carbon number 6. So there are 3 more bonds which are attaching 3 hydrogen atoms. Now the carbon branch. This is the carbon branch. It has 1 bond to carbon number 4. So there are 3 more bonds that will attach 3 hydrogen atoms. Similar goes to this carbon branch. It has only 1 bond. So the other 3 will attach 3 hydrogen atoms. We are now done with the condensed structure for the first compound. Let's move on to the next compound. This compound has 2 continuous carbon chains. If we were to start counting the carbon from this end, carbon 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 carbon atoms in this continuous carbon chain. If we were to start from this end, there's 1, 2, 3, 4, 5, 6, 7. only 7 carbon atoms, meaning that the parent chain starts from this end. Now we will give number to each carbon atom. Okay, next we're going to write 8 carbon atoms in a row. Getting back to the skeletal structure, the third carbon has 1 carbon branch. So this is the third carbon, write a line and write the carbon atom. The fourth and fifth carbon are doubly bonded. This is the fourth and fifth carbon. In between, we have to put a double bond. Carbon number 6 attach a bromine atom. So this is carbon number 6. Write a line and label the bromine atom. And the last carbon, number 8, is attached to a hydroxyl or OH group. So this is carbon number 8. Write a line and label the OH group. So we are now done with the carbon skeletal and the branches. Next, we are going to count the hydrogen atoms on each carbon. Now I'm going to show you another method without referring to the skeletal structure. Looking at this condensed skeletal, the first carbon has 1 adjacent carbon attached. So the 3 other bonds will be attaching 3 hydrogen atoms. The second carbon here has 2 adjacent carbon on the right, on the left, meaning that it has 2 bonds right now. The other 2 bonds will attach 2 hydrogen atoms. The third carbon right now has 3 adjacent carbon on the right, top and left. So the fourth bond will attach 1 hydrogen atom. The fourth carbon, it has 2 bonds here and another bond to this adjacent carbon on the left. So there's 1 more bond that will attach a hydrogen atom. Similar goes to this carbon. Yeah, it has 2 bonds here and another one to this adjacent carbon, so total 3. Another bond, the fourth bond will attach a hydrogen atom. Okay, carbon number 6 has 3 adjacent atoms, 1, 2, 3. So the remaining bond will attach 1 hydrogen atom. Carbon number 7, it has 2 adjacent carbon, meaning that it has 2 bonds right now. One to the right and the other to the left. The 2 remaining bonds will attach 2 hydrogen atoms. And carbon number 8. Carbon number 8 right now has 1 bond to oxygen atom and 1 bond to this adjacent carbon. So it has 2 more bonds that attach 2 hydrogen atoms. This carbon branch clearly shows it has only 1 bond right now. So 3 other bonds will be attaching 3 hydrogen atoms. So we are done with the condensed structure for this second compound. This is the third compound. It is a cyclic compound. Now we will start numbering the carbon on the ring. The number may start from any carbon and you can go clockwise or anti-clockwise. So now what we're going to do is to write the 5 carbon atom and join them together in the shape of a pentagon. The third and fourth carbon are doubly bonded. So now we're going to add a line in between the third and fourth carbon. The second carbon is bonded to a chlorine atom. So draw a line and draw the chlorine atom. It is also bonded to a carbon branch. So now we draw the carbon branch. Next is to fill in the hydrogen on all the carbon atoms. So this carbon has 1 bond. Remaining 3 bonds will attach 3 hydrogen atoms. The next carbon, this carbon has 3 bonds right now. So the fourth bond will attach a hydrogen atom. The same goes to this carbon. Right now, it has 3 bonds, 2 and 1 here. So the other bond will attach a hydrogen atom. And this carbon number 5, right now it has 2 bonds. So the remaining 2 bonds are attaching 2 hydrogen atoms. The same goes to this carbon. 2 bonds right now, another 2 hydrogen attached. And for this carbon, it is already expanded, showing the 4 bonds. So there's no hydrogen attached. Now we are done with the condensed structure of this cyclic compound. Move on to the next compound. We are going to number the parent chain, but the parent chain involves an oxygen atom. The rest are all carbon. So 8 atoms. Now we're going to write all the 8 atoms in a row, starting off with 5 carbon in a row, followed by an oxygen and 2 more carbon. Okay, let's get back to this skeletal structure. On carbon number 2, a chlorine atom is attached. This is carbon number 2. Draw a line and attach the chlorine. Carbon number 5 is doubly bonded to oxygen atom. This is carbon number 5. Write a double bond and the oxygen atom. So we are now done with the carbon skeletal. Next is to fill in the hydrogen atoms. So the first carbon here already has 1 bond to the adjacent carbon. Remaining 3 bonds will attach 3 hydrogen atoms. The second carbon has 3 bonds, 1 to the carbon on the right, 1 to chlorine and the other to the carbon on the left. So 1 more bond will attach the hydrogen atom. Third carbon already has 2 bonds bonded to adjacent carbon on the right and on the left. So the other 2 bonds will attach 2 hydrogen atoms. The fourth carbon is similar to the third, 2 bonds right now. So 2 more bonds attach 2 hydrogen atoms. For this carbonyl carbon, it already has 4 bonds. 2 to this oxygen atom, 1 to the oxygen atom on the right, and another one to the adjacent carbon. So there's no hydrogen atom attached. Since we leave a gap in between, we shall just write a line. Oxygen form a maximum of 2 bonds. So right now it has 1 bond to the adjacent carbon and another to this adjacent carbon. So it has the maximum of 2 bonds. There's no more hydrogen attached. Okay, this is carbon number 7, or atom number 7, yeah, it's carbon. Right now it has 1 bond to oxygen atom and another one to the adjacent carbon. So there will be 2 more bonds attaching 2 hydrogen atoms. And the last carbon atom has 1 adjacent carbon atom. So the other 3 bonds will be attaching 3 hydrogen atoms. So this is the condensed structure for this structure number 4.